The chain rule. Sorry. We're going to talk about the chain rule. So you got the quotient rule and the product rule down now. So the last rule that we're going to talk about is the chain rule. And the chain rule is going to deal with composite functions. So it means functions of functions. So in other words, if you look at this function, it's a composite function because you have this, which is a function, let's call that g of x, inside of a power, which is another function of x. So in a sense, what we're saying is you have two functions here. You have f of x, which is x squared, and you have g of x, which is 2x squared plus 2. And then what you're doing is you're taking f of g of x. That gives you 2x squared plus 2 squared. So that's what I'm talking about. And we did this last year, the f of g of x stuff. So what does the chain rule say to do with that? We have a power rule. So if it's just a power, if it's just x squared, we can do that. But it's not just x. It's this function of x. So what do we do? So here's what the chain rule says to do. Okay. Essentially what it says is you start from the outside function. So if you have f of g of x, then you take f prime of g of x. So you leave the inside alone and you take the derivative of the outside function, meaning in our case, we take the derivative as if it's x squared, but leave g of x in there. And then we take the derivative of the g of x. So what does that mean? Well, we're going to do the power first. So we treat it as if it's just x squared. It's not just x, but we pretend that it is. And so we just go, that's 2 to x to the 1, but x is this function, g of x, so we just leave it there. And then we proceed to multiply by the derivative of this. So the derivative of that is 4x. Okay? So that's the chain rule. That's how it works. We're not going to prove that rule. If you want to see the proof, it is in the textbook. In Leibniz notation, we kind of say dy by dx is dy by du times du by dx. You'll sometimes see that. And what that's saying is basically if I have a composite function like this, y equals x squared plus 3x plus 2 to the 10th power, we make a substitution. We say let u be this, x squared plus 3x plus 2, which means y is just u to the 10th. Okay, if we make the substitution. So then we take the derivative of y with respect to u, so we just pretend that this is our variable for now, and that's 10u to the 9. And then we multiply that by the derivative of u with respect to x, so the derivative of this, x squared plus 3x plus 2. So the derivative looks like that. It's this times this, with u replaced back as x squared plus 3x plus 2. So that's how you use Leibniz notation. And sometimes your textbook sort of goes back and forth. So sometimes you'll see Leibniz notation where it'll say, do this with u equaling this. And sometimes it'll say, just take the derivative and use Newton's notation. So here's another example. Okay, and what we're going to try to do is we're going to try to take the derivative by looking at what's the biggest function, what's the outside function first. So what I'm saying by that is if I sort of look at this function, I've got this inside, but it's inside of this square root, right? So the biggest function is the square root. So what's the derivative of the square root of x? Pretending that's x. We know that's 1 over 2 root x. So I'm just going to replace it with 2x squared plus 3. So we write it as if we're just taking the derivative of the square root. And then we multiply by the derivative of what was inside the square root. So the derivative of 2x squared is 4x. And the derivative of 3 is 0. So you get that. And then that simplifies. If you cancel those, make that a 2. You can write it as 2x over the square root of 2x squared plus 3. Okay, so there's my derivative. That's the answer. Okay, here's another example. And you'll notice that these things can get pretty large pretty quickly. And I'm going to erase this because I want you to see the process. But we're going to start here. We're going to look at the fact that this is a function 2t minus 1 over t plus 2, but it's raised to the 6th power. So we have to deal with the power first. So we kind of pretend it's just x to the 6th. Okay, so we use the power rule first to deal with the 6, and that's 6 times whatever this is to the 5th. And then we multiply by the derivative of this. And this is a quotient rule. So it's the bottom, which is t plus 2, multiplied by the derivative of the top, which is 2. Okay, derivative of this is just 2. Then it's minus the top, so 2t minus 1. Multiplied by the derivative of the bottom. The derivative of t is 1. And the derivative of 2 is 0, so we just get that. And it's all divided by the bottom, which is t plus 2 squared. Okay, and you can simplify this further, and I think I did down here, so you eventually get down to this. Okay, but we're going to just worry about, at this point, do you know how to use the chain rule to get the derivative, okay, and not simplify it. So that's how you use the chain rule for that one. And this can get progressively more complicated. All right, so let's say I gave you a question like this. And you can see, because I haven't erased it yet, that this is a rather large mess. But let's go through it. And then we'll see where we go. So we have a function multiplied by a function. So the biggest operation is this guy. It's a product rule. So we're going to do the product rule. The product rule says take that first function, 4x plus 2 over 2x squared cubed, and multiply it by the derivative of this function. So in here, this is the biggest thing that's going on. It's a power, so we're going to go 2 times 3x plus 2 over 4x. Oops, this is, just bear with me a second here. My penmanship is not the greatest here. 3x plus 2 over 4x plus 1. And then we have to multiply that by the derivative of what's inside. So the derivative of that is going to be the bottom, which is 4x plus 1, multiplied by the derivative of the top. The derivative of 3x plus 2 is 3. Then it's minus the top, which is 3x plus 2, times the derivative of the bottom. The derivative of 4x plus 1 is 4, divided by the bottom, 4x plus 1 squared. Okay, so what this is, that's the first function. And this whole thing is the second prime. And then we're going to go plus the second function, which is 3x plus 2 over 4x plus 1 squared, multiplied by the derivative of this guy now. So we're going to do the power first. 3 times 4x plus 2 divided by 2x squared. Squared, we do the power, then we do the quotient rule. So it's 2x squared, the bottom, times the derivative of the top, which is 4, minus the top, which is 4x plus 2, times the derivative of the bottom. The derivative of the bottom is 4x, all divided by the bottom squared. All right, there we go. So we're going to do some more practice with that, but that's the chain rule. And you can get more and more complicated as you go, but that's how you do it. And just understand that it's just basically giving you an order of how you do the derivative. Okay, so it's the more complicated one. We'll practice more of it in class, but that's the premise of the chain rule.